3 videos in the same day? Why, yes indeed. Hello, it's me, the scruffy, unprepared version. And I'm making this video because after feedback from patrons of the original humidifier video, A, they reminded me that I forgot to address something, and B, there's some other information that I want to actually bring to light because it is useful. First, okay, I've made an editing job for myself because I want to put this first, but one thing that I'm worried I didn't effectively convey in that video, I'm on the fence. You tell me if I did it or not. I wasn't trying to say that the evaporative humidifier style is the best. I think that it is the most effective when it comes to amount of water it can put into the air versus the amount of energy it requires to do so. But the next section of the video that I just recorded will explain why that itself is a little complicated. But it's not like cool mist evaporator or cool mist humidifiers are universally bad. If you don't have very hard water, they're fine. There are also treatment products. There are like cartridges that you can put in the water tank that help basically descale the water before it ends up in the air. Couldn't tell you how those work, but from input from a patron, they seem to work really well. So there are options to help deal with that particular problem. But then on the other hand, some people talked about how the white dust actually killed computer equipment of theirs. So, you know, it's complicated. But this style, I still just, as far as, because of the way it works, if you haven't seen the video where I took this apart, these are just, I would consider actually quite high maintenance. Depending on your water, perhaps not. But in addition to being pretty... Oh, hang on, the furnace just started. I'm gonna make that stop. Oh boy, I've tried to make this simple. Now I gotta edit this. Right, so depending on your water, this may not be as high maintenance as it has been for me, but just, I still don't really care for this style, but you will find out in a moment that the energy concerns are complicated. But I should address, because I was gonna bring that up, I have now properly descaled this and filled it up all the way, and it is still consuming about 250 watts. So it seems to be that the level of the water doesn't really affect how much energy it needs, which is kind of interesting. My suspicion is that the chamber that it is actually boiling the water in, something about its size regulates the total amount of water that it's boiling, or simply the latent heat of vaporization affects how much power it's going to draw. Because if you haven't seen that video, spoiler, this is an electrode boiler. It's just two, I believe, carbon electrodes pointing sticking into the water with a gap of about, it's like, I don't know, 1.5 centimeters between the two of them. And that's it. So extremely simple devices. So that's the good thing about these, is they are very cheap because it's as simple as you can. It's almost terrifyingly simple. But now, the section I just recorded. I have this problem where I make videos and then I think that all of you have seen all of them, which is very dumb. And I even knew that, like, hey, many of you have not seen the video about this thing. Maybe you should watch that. But then I just assumed that everyone's going to watch it and we're going to then come to the logical conclusion that I have in my head. But I didn't say it, and so I'm saying it now. If this is a swamp cooler, and swamp coolers are a thing, then don't evaporative humidifiers cool the air? And the answer to that is technically yes, effectively maybe. So it takes energy to get water to evaporate. No matter how you do it. This thing is heating the water until it boils. That's one option. If you allow water to evaporate on its own, like an evaporative humidifier does, it still needs energy to get from liquid to gaseous, and that latent heat will come from ambient air. Now, the reason why it's complicated is that the effect of this seems to be affected by what ambient humidity actually is. That's why these things don't really do anything for you when the air is very moist. But that's really more of a function of the fact that when the air is very moist, evaporation happens more slowly. So when the air is very dry, a lot of water is coming out of this thing, or indeed an evaporative humidifier, which means a lot of water is evaporating, which means the actual temperature is falling a lot. Complication, though, is that this energy has to come from somewhere, and if you have, say, electric resistance heating, then it makes absolutely no difference if you use this, because this will just offload some of the load that your electric heaters would be taking care of, and then in the end it makes no difference whatsoever, because that's how it works. An evaporative humidifier, though, if you use it, it's going to make your heater work a little harder. So in that situation, you could say there is no difference between a boiling device and an evaporative cooler. But it gets complicated a little bit more when you consider that if you use a humidifier, you can lower the actual temperature that you need, but I suppose it doesn't actually change the equation because this would still have the same effect. If, however, your home heating system is either cheaper to run or more efficient or both, say natural gas or a heat pump, then it would make sense to just have that work a little harder when you use an evaporative cooler. And then it does get a little, then the savings do become more prevalent when you are able to run the heat lower. Or maybe not, I don't know. I don't know if that math works out or not, but I am just saying that, yes, it was an oversight of me to not explain that evaporative cooling does still happen, even though its purpose isn't to cool, it's just to humidify. But its effect is, I would argue, negligible once humidity is where you want it to be. Because when you feel the air that comes out of these humidifiers, if it's 40% humidity or above, it really doesn't feel cool at all. It is, if you actually measure the output temperature, it's about 4 to 5 degrees, perhaps lower than ambient temperature. But it's not really significant. It's not something you're going to notice. It's not like when the humidifier comes on, you're going to start to feel cold. And in fact, my humidifier, because it lags the furnace like it does, you would expect that because it's near to the thermostat, perhaps it would cause the furnace to come right back on right away, but it doesn't. There's, as far as I can tell, no change in behavior to the way my furnace is actually running, except I suppose it may be running just a little bit more per cycle, but I haven't noticed. I'd have to look at reporting to see that difference. So again, it takes energy to make water evaporate, no matter how you do it. So the fact that this is actually just boiling it and then heating the space, it's not as big of an energy concern as I perhaps thought it was, but it is still the case that an evaporative humidifier, especially if you have more efficient than electric resistive heating, which you probably do, but that's not a given. In that case, an evaporative humidifier would, and this, there is really no energy difference between the two. In fact, possibly an evaporative humidifier would use slightly more energy because then the fan is just, well, no, that's not true because that just ends up being waste heat anyway. Ignore that. Winter makes things complicated because waste heat ends up helping your heating system. And that's, again, why energy efficiency is kind of a complicated topic. Fun fact, like 6 or 7 years ago, I was going to make, I think it was before Technology Connections even existed. In fact, I'm pretty sure it was because I would have put it on the channel. I was talking about how in the winter, incandescent light bulbs aren't really a problem. But again, that's still not super true because it just depends on your energy mix, really. If you have 100% renewable energy in your area, by all means, incandescent bulbs in the winter, they just lower your heating demand, or the demands on your furnace. They lower the heating demand. They help with the heating demand. Language. But nowadays, we have more efficient heating. If you have natural gas heating, that's less expensive because it's more effective to just utilize gas on site rather than turn it into electricity. Anyway, that's neither here nor there. And now, the final section. So too much humidity is a bad thing. And I didn't really talk about this because I didn't assume that this would be something that people didn't just intuitively know, but that was probably a mistake on my part. But also people who are going to seek out a humidifier, I would hope are going to at least read the instructions where it will tell you that. But a thing that I didn't even know was a possibility but makes perfect sense in hindsight is that if it gets extremely cold outside, it's not a good idea to keep humidity very high. And by very high, it might even be as high as 50% inside, because what can then happen, which is like, well, that's slightly terrifying, is the moisture in the air can then condense on like the structure of your home. So if it's wood studs, like the outside surface right up against your siding or whatever, that is very, very cold. And if the air is able to get there, then water will condense on that. And that can cause long-term damage, so that's exciting. And apparently some humidistats for whole home systems will actually have an outdoor temperature probe to automatically reduce their output when it does get extremely cold. I would say a good litmus test for if it is problematically humid, this is my own supposition, so like don't take my word for this, but I would say if you start to notice like condensation on like your window glass or window frames, because those are going to be pretty much the coldest things that you can see in your environment, turn the humidity down, because then you know this, if the moisture in the air is condensing on your windows, that on the inside surface, it might be condensing in places you really don't want it to be. And that's ultimately what that's the reason why the humidifier has to keep working, is just because water condenses, it will condense on colder things, and that's why over time moisture just gets lost. And then of course it's just the exchange of air from inside to outside, but it is still pretty common building practice here in the US, which is another thing that's interesting. We still, for the most part, build homes to be very sealed. We don't have airflow going in and out, which we are now learning is probably not great for various reasons, but it's, basically 50 years of energy policy hasn't been updated. So our building envelopes are often very, very sealed. And so some people were surprised that the humidity does not drop until the furnace runs again. And that's why there's basically no movement of air, no exchange of air between inside and outside, unless you either open a door or are like using a vented dryer or a bathroom fan or something like that. There are ways to force negative pressure to happen, but generally we still to this day consider that to be quite bad, but we really need to have a reckoning and rethinking on that. But yeah, humidifiers are not foolproof, but I would still, for that reason, say you want one with a humidistat, because this one, if it really does output, which I've never like timed it, but I would believe it. If this really only takes 12 hours to go through its tank of water, then this is pretty close to the amount of humidification I need for this building, which isn't that big. And if that's the case, then yeah, if I didn't have a humidistat, this could be over humidifying, depending on conditions. Right now, it wouldn't be, because it's about in line with what the big one is using. But you don't want too much humidity. It's not good. And the humidistat on these units from Air Care, you can't set it higher than 65%. And to be clear, that is, to me, uncomfortably moist. Like, already I'm on the fence between setting it at 45 and 50%. I've been staying with 50 because it's helping my skin more. But when it does get really, really cold, I'll probably turn that down to 40% for just those other considerations. Oh, other notes. I only focused on the 3 common styles of humidifiers, which are this, evaporative, and ultrasonic. There are other weird various side things, and in fact, console humidifiers have changed. Apparently there used to be like a belt in them. Don't know the specifics on that, but I've seen both, like my dad was talking about, they had one a long time ago, and I saw comments online. People are like, the old belt style units were better. Don't know the specifics there, but it seems in 2021, everything that's available is either ultrasonic, evaporative, or some version of boiling water. But there was a very intriguing kind that I tried to see if it's still available, and I would have actually tried to track one down before I made the video, and that was an impeller humidifier, which is apparently a mechanical means of producing clouds like ultrasonic humidifiers do. It's very intriguing to me, but it has the same disadvantages of white dust, and I didn't see any available online. So perhaps they're still manufactured, but it looks like they've gone out of fashion. Okay, so I think that's about it for this supplemental ramble. Just to recap again, evaporative cooling is a thing that still happens even when cooling is not your goal, which complicates the energy efficiency discussion because, yes, this thing may pull 250 watts all the time, but that's 250 watts of heating rather than these, which are going to basically produce negative heat and require more effort from your furnace. Or heating system. This gets complicated by the fact that you could turn down your heating system, but you could still turn down your heating system with that. We didn't really establish that, but I am just saying that the watt hours per gallon figure that I came up with doesn't really mean anything for end-to-end efficiency because it's just more complicated than that. But we got that. We got you don't want your humidity to be too high. It can be bad for your stuff. And the other kinds of humidifiers. I think that's it. Sneak peek or no, you're not getting a peek because I don't have it yet. But a thing that is coming is a very interesting personal care device. That I had, personal care device might lead you down the wrong mental path. Personal care product that I had learned about, I don't know, like 8 years ago, and I bought some and I lost them. So I have new ones coming that are hardly a technology, but it's a really fascinating discussion. And I'll probably just do a quick main channel video about it because there's a lot of it. It's just fascinating. I don't want to spoil it, but like, it's really neat. It's a thing. It's a very counterintuitive physical property of this thing. So we will explore that. And the heat pump video, that's going to be coming fairly soon. So then we'll talk about the refrigeration cycle yet again. But for now, thanks for watching. And yes, I may go over everything in this set as like a 1 million subscribers special. Very late because, you know, already made a video after that happened, and thank you very much for subscribing. But yes, that's a thing that people have asked about have asked for is to go through and explain everything that's in here. So I might do that as a more casual video, but for the main channel. So if you'd like to see that, let me know. And I had another thought. Oh, another junk box. I'll probably do that. I realize the last one was in April. This year has just been a year. Okay, bye.